Why would indigenous people, whose technology was supposedly limited to primitive tools and who allegedly didn't even know about iron, create channels in hard rock with perfect geometry and right angles? Modern science claims that all these monumental structures were built by cultures that hadn't even invented the wheel. Yet the marks on the stones suggest otherwise. There are places where mountain rock has been sliced through like a stick of butter, and landscapes that are considered unique nature reserves today, upon closer inspection, look frighteningly like the aftermath of massive industrial mining. In this video, we will break down the facts indicating that the so-called colored mountains are not a wonder of nature, but the result of an ancient ecological catastrophe. But before we start destroying your usual perceptions of history, be sure to subscribe to the channel and hit the like button. It helps the truth break through the wall of academic dogma. Our investigation begins in northern Peru, near the city of Cajamarca. Here, at an altitude of over 3,000 meters above sea level, lies a site known as Kumbemayo. Official guidebooks call it an aqueduct or an artificial water channel laid by ancient masters. However, any engineer looking at the structure of this channel will spot inexplicable oddities. The channel, carved directly into the rock massif, is full of perfect 90-degree turns. From the perspective of hydrodynamics, this is an absolutely senseless decision. Water slows down at such turns, creating congestion and eroding the walls, whereas smooth, natural curves would have been much more efficient and easier to execute. Historians try to explain this geometry by citing the aesthetic preferences of the Incas, or the use of pre-existing natural cracks. But nature rarely creates perfect 90-degree angles that stretch for kilometers. Moreover, the walls of the channel in many places are strictly vertical, and the cut line passes right through the cliffs, ignoring their hardness and structure, as if obstacles didn't matter. This looks more like the trace of a tunneling machine, or a giant disc cutter, for which it is simply more convenient and faster to move in straight lines than to navigate around obstacles by hand. The theory of copper chisels and stone hammers falls apart when it becomes obvious that these so-called aesthetic curves are actually technological markers of machine processing. If you walk just a couple of kilometers away from the channel, you can find even more amazing evidence. The area known as the Stone Forest is filled with rocks that show not signs of wind erosion, but clear, even cuts, as if someone removed the rock in layers. A similar picture is observed at a place called Ventanias de Otusco. This site is called an ancient necropolis because it is a cliff face riddled with square and rectangular niches. The peculiarity of this place is that the niches are carved into volcanic rock. The interior of such rock can indeed be relatively soft and pliable, but it is hidden under an extremely hard outer crust formed by cooling lava and centuries of atmospheric exposure. Historians happily point to the softness of the inner rock, claiming one could hollow out a niche with a stick, but they intentionally ignore the main question. How did ancient masters overcome the outer, super hard layer? The edges of the niches have perfectly even geometry, without the chips and cracks that would inevitably occur with impact techniques. The cut looks as if the top layer of stone was neatly removed by a high-speed milling cutter, after which the soft core was removed mechanically. This place looks more like a testing ground for calibrating mining equipment, where operators adjusted the depth and shape of the cut, rather than a sacred resting place. Even harder to explain is the phenomenon of Aramu Muru, a mysterious doorway in the rock, which local legends call a portal. Here, the quality of stone processing reaches a level where denying machine intervention becomes practically impossible. The corners inside the recesses are sharp and even, the surfaces are polished, and along the edges, there are traces characteristic of a milling cutter's pass. Doing something like this with primitive tools while maintaining geometry along the entire length of the cut is physically impossible. All these objects share one thing. They look like the remnants of high-tech production, not the ritual structures of tribes struggling for survival. Located at a dizzying height of 3,300 meters, this object represents a real challenge to common sense if viewed through the lens of official history. Before us is hard bedrock, volcanic stone, which is difficult to process even with modern tools. And yet, some force cut a long trench into this massif, which is considered an ancient water pipeline. However, upon detailed study of the engineering features of this structure, the theory of its hydrotechnical purpose begins to burst at the seams. Any expert in hydrodynamics will confirm that water flowing through a channel strives for smooth movement. Natural riverbeds are always winding, but their curves are soft and streamlined. Here, we observe a picture that contradicts the physics of flow. The channel makes sharp turns at a strict 90-degree angle. Such geometry is disastrous for transporting water. Right angles create turbulence zones, kill the flow speed, and contribute to the rapid silting of corner pockets. If the builder's goal was to deliver water for irrigation or drinking, they would have simply slightly straightened natural cracks, or cut a smooth path, saving a colossal amount of effort. But the creators of this object, with maniacal persistence, cut zigzags into the stone that only complicated the task. This makes one think that the function of this channel was completely different. Such geometric solutions, even vertical walls, right-angle turns, constant depth, are characteristic not of irrigation, but of industrial chases into which cable routes are laid. Or they are the traces of the passage of mining machinery that had a rigid frame and a limited turning radius. We are particularly baffled by the explanations of academic scientists who, when faced with such inconsistencies, resort to a universal argument. This is how the artists of antiquity saw it. We are asked to believe that tribes whose lives were a continuous struggle for survival spent precious calories and years of labor to give a ditch an aesthetically pleasing square shape. Allegedly, ancient masters intentionally made their work harder for the sake of beauty that no one would appreciate. This version does not hold up to criticism, especially when so-called superfluous cuts are found near the main channel. In the bedrock, rectangular scoops and depressions are visible that have absolutely nothing to do with water drainage. They lead nowhere, cut off abruptly, or are located so that water would never get into them. But these traces match perfectly with what a test pass of a cutter looks like, or the mark of a side cutter of a huge mechanism biting into the mountain. The walls of these cuts have a strictly vertical orientation in all planes, which is practically impossible to achieve with manual chiseling without the use of precise measuring instruments and guides. The surfaces look as if they were milled, not chipped out with a chisel. The absence of chips characteristic of impact techniques and the amazing smoothness of the stone point to the mechanical impact of high speed and power. All this suggests that we are looking not at a sacred aqueduct, but at the remains of technological infrastructure or a byproduct of massive mining operations. And if here we see only scars on the body of the rock left by an unknown tool, then just a few kilometers to the north, the landscape changes even more radically, demonstrating that stone cutting here was conducted not selectively, but systematically, grinding down mountains on an industrial scale. If we move a little further from the mysterious channels towards the so-called stone forest, the scale of technological anomalies only increases. Here, among natural cliffs, hides the site Ventanias de Otusco, which translates as the Windows of Otusco. Academic science, finding no better explanation, hastened to label this place an ancient necropolis. According to the official version, the Indians buried their dead in these numerous square and rectangular niches. However, upon detailed inspection of this rock wall, the cemetery version begins to seem, to put it mildly, a stretch. The windows are arranged chaotically, without any systematic sacred geometry characteristic of burial places, and resemble a trial run, or rather, a tool test. Geologically, these rocks are volcanic. A peculiarity of such material is that its inner part can be relatively loose and pliable, but it is hidden under an extremely hard outer crust, formed by the solidification of lava and centuries of atmospheric exposure. Historians happily point out the softness of the inner rock, claiming that a niche can be hollowed out almost with a stick. But they intentionally ignore the main question: how did ancient masters overcome the outer, super strong layer? The edges of the niches have perfectly even geometry, without chips or cracks that would inevitably arise from impact processing techniques. The cut looks as if the upper layer of stone was neatly removed by a high-speed milling cutter, after which the soft core was scooped out mechanically. This place looks more like a proving ground for calibrating mining equipment, where operators adjusted the depth and shape of the cut, than a sacred place of rest. Even more impressive traces of mechanical processing can be found at a place called Hayu Marca, known as the Portal of Aramu Muru. This is a gigantic, perfectly flat wall, machined directly into a massif of red sandstone, with a T-shaped recess carved in the middle. Local legends call this the Gate of the Gods, but from a technical point of view, we are looking at a masterpiece of machine cutting. The corners inside the recess and the side edges have incredible sharpness. The inner corners, where the planes meet, are executed so sharply and evenly that it is impossible to get in there with any primitive impact tool without damaging the adjacent surfaces. A chisel or stone hammer leaves characteristic traces of microdestruction. Here, the surface is smoothed. Moreover, on the side faces of the portal, under side lighting, longitudinal grooves and stepped depressions clearly appear. This is a classic sign of multiple passes of a cutting tool. Similar marks are left by a circular saw or a milling cutter when it is impossible to remove the entire necessary volume of material in one pass, and the master is forced to go over the same place several times, shifting the tool slightly. The geometry of these steps is strictly parallel, which rules out manual labor. A person with a chisel cannot maintain perfect parallelism of lines over several meters while working with hard stone. Aramu Muru looks not like an unfinished temple, but like a residual element of some gigantic structure, or, perhaps, the result of extracting a core sample of incredible size. But if cutting hard stone with discs and cutters can still be comprehended within the framework of paleo-contact theory or lost technologies, there are artifacts that stump even engineers. Because in some places in the Andes, granite wasn't cut. It seems it was turned into a soft mass, molded into shapes like children's plasticine. Moving further south, into the very heart of the sacred valley of the Incas, we find ourselves in the area of the ancient capital, Cusco, and the famous Sacsayhuaman complex. If in northern Peru we observed traces of ruthless machine cutting, here stone processing technologies reach a qualitatively different, almost transcendent level of understanding. Local megalithic structures make one question the hardness of granite and andesite as a physical property. Researchers are faced with walls made of blocks weighing tens and sometimes hundreds of tons, which are fitted together with a precision unattainable even for modern construction. This is the famous polygonal masonry, where stones have a complex, multifaceted shape, yet fit together without a single gap, like parts of a giant mosaic. Looking at these joints, it is difficult to shake the feeling that the stones were not hewn, but cast or molded. The contact surfaces of the blocks are not just flat. They perfectly repeat the slightest curves of their neighbor, creating a so-called lock effect that makes the masonry earthquake-resistant. Official science offers a version of long and painstaking grinding of stones using sand and water, but anyone who has ever tried to process granite by hand will understand the absurdity of this statement when applied to blocks the size of a truck. Much more logical seems the hypothesis of geopolymer concrete, or an unknown technology for softening rock. The stone looks as if, at the moment of laying, it was in a plastic, jelly-like state, and under the influence of its own gravity, it settled, filling all voids and taking the necessary shape. This phenomenon of plasticine stone becomes even more obvious if we look at the rock outcrops around the fortress. Here you can find steps and niches that are not carved, but literally pressed into the solid rock. The corners of these steps often have smooth, melted edges, characteristic of working with soft clay or dough, not with crystalline material. But the most blatant example, destroying the picture of the primitive world of the Indians, is the neighboring diorite hill. Diorite is one of the hardest rocks on the planet, requiring diamond-tipped tools to process today. However, the surface of this hill looks as if a giant spoon had been run over it, scooping up the stone like soft ice cream. The rock here has no chips or impact marks. It is smooth, with characteristic wave-like depressions that could only have been left by a tool capable of changing the aggregate state of matter or a mechanism removing shavings from hard stone with incredible ease. These traces are chaotic and massive. The hill itself resembles a solidified mass that once boiled or was molten. A comparison with modern methods of thermal processing or plasma impact suggests itself. Tools capable of this do not just cut. They ignore the resistance of the material. However, everything we see in Peru is in essence traces of construction or local terraforming. The real shock comes when you realize that these technologies were used not only to build walls, but also to empty the bowels of an entire continent. And to see the true scale of this industrial mining, we will have to leave Peru and go to Argentina, where entire national parks look not like nature reserves, but like abandoned quarries of cyclopean proportions. Leaving the mysterious ruins of Peru, where stone was subjected to point and virtuoso processing, we move to the southeast of the continent, to the Argentine province of La Rioja. Here, in the Talampaya National Park, the character of the traces changes radically. If in Cusco we saw jewelry work with megaliths, the Argentine landscapes reveal to us a picture of rough but massive industrial intervention. Official guidebooks describe Talampaya as a miracle of nature formed by wind and water erosion over millions of years. However, upon careful examination of the sheer cliffs of the canyon, it becomes obvious that natural forces act completely differently. The chaos of the elements never generates the strict geometric order that we observe here at every step. The canyon walls, rising 150 meters, are not just rocky precipices, but surfaces with traces of mechanical extraction. The most striking element of the local relief is the giant, vertical, semicircular chutes. They stretch from the very top of the cliff to its base, maintaining the same radius of curvature throughout their entire length. Geologists try to convince us that this is the result of wind, which blew out the sandstone for centuries, or rain streams that cut a path. But wind is an abrasive flow that smooths corners and creates bizarre, uneven shapes. It does not work like a high-precision machine, capable of carving dozens of parallel semi-cylinders into stone as if by a template. Water, flowing down a rock, creates V-shaped washouts that widen and wobble, obeying the structure of the rock, not perfectly even U-shaped channels. Any specialist familiar with mining will see in these walls a painfully familiar picture, only magnified hundreds of times. This is exactly what quarry walls look like after the passage of a rotary excavator or a tunneling shield. When a rotating bucket or cutter bites into the rock and moves vertically, a characteristic concave trace remains on the wall. In modern quarries, such traces are several meters in size. In Talampaya, they reach cyclopean scales, which makes one wonder about the size of the machinery that could have worked here. It creates the impression that a giant machine literally sliced off layers of the mountain, leaving behind these even, rhythmic furrows. This is not erosion. These are residual deformations of the massif after the removal of a colossal volume of soil. Moreover, the very structure of the canyon resembles a worked-out open-pit mine. Flat platforms, sheer walls, strange acoustics, and the absence of chaotic piles of stone typical of natural rockfalls. All these are signs of the artificial origin of the landscape. We are looking not at a reserve where nature created beauty, but at an abandoned resource extraction facility of planetary scale, which over time has only slightly been covered with a patina of weathering. Imagine a rotor with a diameter measured in hundreds of meters biting into sandstone. Precisely such a picture best explains the geometry of Talampaya. But if mining was conducted here, then accompanying tools or consumables must have remained. And indeed, quite close by, literally next door to these giant quarries, scattered across the ground are objects that science calls another mystery of nature, but which frighteningly resemble industrial consumables for crushing rock. We are talking about fields strewn with perfectly round stone spheres. Just 80 kilometers from the giant trenches of Talampaya Park lies another territory that raises no fewer questions for researchers: Ishigualasto Provincial Park, often called the Valley of the Moon. This deserted, alien landscape is literally strewn with mysterious stone formations of perfect spherical shape. The balls are scattered across the valley in a chaotic manner. Some lie in groups, others stand lonely in the middle of the wasteland, and others are half submerged in the ground. The sizes of these spheres vary from small, comparable to a cannonball, to huge monoliths taller than a human. Official geology offers the theory of concretions, a natural process in which minerals accumulate around a certain central core, forming a ball. However, this hypothesis does not explain why the concretions reached such phenomenal geometric correctness and why they are concentrated precisely here, in the immediate vicinity of traces of massive soil extraction. If we discard attempts to attribute everything to the whims of nature and look at these objects through the eyes of a mineral processing engineer, the picture comes together into a completely different technogenic mosaic. These stone spheres resemble to the point of confusion the so-called grinding media used in industrial ball mills. In the mining industry, the process of extracting minerals begins with crushing the ore. Huge chunks of rock must be turned into fine dust so that the valuable metal can then be separated from the waste rock chemically or physically. For this, giant rotating drums are used, into which ore and hard, heavy balls are loaded. When rotating, these balls roll, fall, and grind the rock into flour with their weight. In modern industry, balls made of high-strength steel or cast iron, as well as ceramic and silicate products, are most often used for these purposes. However, the principle remains unchanged for millennia. The spheres in Ishigualasto look exactly like worn-out grinding media of antiquity. Many of them have characteristic signs of wear, encircling stress lines or splits typical of objects that have experienced colossal impact loads in a confined space. Their material is significantly harder than the surrounding sedimentary rock, which is logical. The tool must be stronger than what it destroys. The presence of a huge number of such balls under the open sky suggests that we are facing not a nature reserve, but an abandoned warehouse of consumables or a dump of worn-out equipment left after the closure of a giant mining and processing plant. If we accept this hypothesis, then the puzzle begins to come together. In Talampaya, we see a quarry where rock was mined. In Ishigualasto, we find tools for its crushing and grinding. These are links in one production chain, indicating the existence here in the past of an industrial complex, in scale not inferior to, and possibly exceeding, modern enterprises. But any production cycle for ore enrichment inevitably faces the problem of waste. When only a few grams of gold or uranium are extracted from a ton of ore, hundreds of kilograms of processed, chemically active waste rock remain. Where did these millions of tons of waste slag go? They didn't disappear without a trace. The answer lies on the surface, in the most literal sense of the word, and millions of tourists admire this spectacle every year, not even suspecting that they are taking selfies against the backdrop of an environmental disaster zone of planetary scale. The most striking, and at the same time the most frightening proof of the existence of an ancient industrial civilization are objects that millions of people today consider masterpieces of natural beauty. We are talking about the famous Rainbow Mountains, located in different corners of the planet. From the Peruvian mountain Vinicunca and the Argentine Hornocal Range to the colored rocks of Zhangye Dangsha in China. Tourist brochures describe these places as a geological wonder, where layers of sedimentary rocks formed over millions of years were painted in bizarre colors due to complex natural processes. However, if we discard poetry and turn to chemistry and mining, a truth opens up that can overturn one's worldview. The color of these mountains is unnatural for a normal mountain landscape. Bright red, ochre, turquoise, purple, and toxic yellow are the colors of active metal oxidation. Red and brown shades are provided by iron oxide. Green and blue indicate the presence of copper and its compounds. Yellow is a clear sign of sulfur, and purple often testifies to the presence of manganese or lithium. In a natural environment, these elements are usually hidden in the thickness of the rock or distributed evenly, without creating such concentrated and clearly separated color bands. Such segregation, when one layer consists of copper oxides and the next of sulfates, is characteristic not of geological layering, but of the process of chemical leaching or ore enrichment. If you visit modern active or abandoned quarries, for example, the Sokolov-Sarbai deposit in Kazakhstan, copper mines in the USA, or rock dumps in the Urals, you can see an absolutely identical picture. Waste rock, from which the useful component has been extracted, is dumped into huge spoil tips. Under the influence of air and rain, residual metals in this loosened mass begin to actively oxidize, painting the slopes of artificial mountains in those very rainbow colors. Modern dumps look like twins of the ancient sacred mountains of the Andes. The difference is only in age. The Peruvian and Argentine dumps have had time to settle, partially petrify, and become covered with a crust of weathering, but their essence has not changed. The layering of the Rainbow Mountains, which is passed off as geological epochs, actually resembles layers of dumping formed by giant dump trucks or conveyor belts. A layer of waste rock of one type, then a layer of another, depending on which seam was being developed in the quarry at that moment. This explains both the looseness of these mountains compared to the surrounding monolithic rocks and the absence of normal vegetation on them. Even millennia later, these places remain zones of chemical pollution, where the concentration of heavy metals and salts makes the soil unsuitable for life. What are called national parks today, and protected as UNESCO heritage sites, are in fact giant dumps of toxic waste left after the predatory processing of the planet's bowels. The scale of these colored burials boggles the imagination. We are talking about billions of tons of processed soil. This means that the civilization conducting these works possessed energy and technical capabilities many times superior to ours. The entire mountain system of the Andes in certain areas looks like one continuous industrial zone, where mountains were first cut by cutters, then ground into flour. Everything valuable was extracted, and the poisonous slag was dumped into huge, picturesque piles that we now admire. But if South America was turned into a giant quarry, a logical question of logistics arises. Where were these unimaginable volumes of extracted resources taken? After all, no traces of cities or factories capable of consuming such a quantity of raw materials remain on the planet. The answer to this question lies in the strange lines covering the desert plateaus and in the geometry of the ocean floor, which preserves traces of transport routes of a global scale. If we accept the hypothesis that South America represented a giant industrial proving ground, the question of logistics inevitably arises. Where and how were these colossal volumes of resources transported? The answer to this question may lie on the arid plateaus of Peru, known to the whole world as the Nazca Lines. Academic science has been trying for decades to convince the public that these giant geoglyphs and strips are astronomical calendars or paths for ritual processions of the Indians. However, if we look at this system from the point of view of engineering infrastructure, a completely different picture opens up. The Nazca and Palpa plateaus are riddled with thousands of perfectly straight lines that stretch for tens of kilometers, ignoring the terrain, ravines, and hills. Particular attention is drawn to wide rectangular strips, similar to the runways of modern airfields, and so-called chopped mountains. The tops of some rock massifs in this region look as if they were sliced off with a giant knife to create a perfectly flat platform. The volume of moved soil with such leveling is calculated in millions of tons, and believing that the Indians did this manually for the sake of ritual dances is decisively impossible. This looks more like the preparation of infrastructure for receiving heavy transport vehicles, or traces of the work of scanning equipment that X-rayed the bowels in search of ore veins. The lines in this context could be traces of geological exploration, markers of rock deposits, or residual traces from the impact of energy installations moving above the surface. But if the Nazca Plateau is just a transport hub or a map of explored resources on land, the true scale of extraction opens up if we turn our gaze to the ocean. Modern maps of the seafloor, compiled using echolocation and satellite data, demonstrate structures that cannot be explained by geological processes. The floor of the Pacific Ocean, especially in zones adjacent to South America and Antarctica, is crossed by strange, straight lines stretching for thousands of kilometers. They run strictly parallel to each other or intersect at right angles, forming a giant grid covering the planet. Nature does not create straight lines of such length. Tectonic faults always have a winding, jagged structure. These underwater formations resemble tracks from the wheels or tracks of gigantic machinery that moved along the bottom when it was still dry land, or worked underwater. The width of the track of such roads can reach several kilometers, and their strict geometry excludes accidental origin. Some researchers draw parallels with modern quarry works, where rotary excavators leave characteristic furrows on the soil. If we scale this picture to the size of the planet, then ocean basins begin to look not like natural depressions, but like giant, worked-out quarries. There is a bold hypothesis that the very shape of continents and oceans is the result of total processing of the Earth's crust. The coastlines of South America on the Atlantic side have suspiciously even cuts resembling quarry ledges, and shelf zones look like terraces down which mining equipment descended. From this point of view, the water covering 70% of the planet's surface is merely a filler, hiding the traces of the main excavation. We live on a planet that resembles an abandoned mine, where the owners scooped out everything most valuable, sliced off the tops of mountains, dug up the ocean floor, and then simply flooded the pits and left toxic dumps to weather under the sun, which we now take for a natural landscape. This explains the strange geography, the anomalies of the seabed, and those impossible tool marks scattered across all continents. Earth looks like a squeezed lemon, a resource base that was used and abandoned. Piecing together all the fragments of this grandiose mosaic, from surgically precise cuts in the rocks of Peru to the cyclopean trenches of Argentina and planetary traces on the ocean floor, we arrive at a conclusion that is frightening in its uncompromising logic. Before us are not scattered riddles of ancient cultures, not whims of erosion, and not a play of light and shadow. We are standing face to face with evidence of the existence of a high-tech civilization for which planet Earth was not a temple or a home, but exclusively a resource base. The scale of the work carried out by these unknown masters is such that our modern industry seems like child's play in a sandbox compared to the giants of the past. They possess technologies allowing them to cut mountain massifs like butter, change the structure of matter, and export billions of tons of ore. leaving behind only waste rock and scars on the body of the planet. The scariest part of this discovery is the realization of our true place in history. Official science and historians, with a persistence worthy of a better cause, continue to ignore obvious facts, hiding them behind a screen of terms like cult structures or geological anomalies. Perhaps this is done not so much out of malice, but out of fear. To admit the technogenic origin of the Andes and ocean basins is to admit that humanity is not the crown of creation, or the first developed civilization on Earth. It means agreeing that we are a cargo cult civilization living on the ruins and industrial dumps left by someone much more powerful. Our sacred mountains are spoil tips, our canyons are quarries, and the foundation of our history is the trash left after global mining of the bowels. We admire the beauty of colored mountains, not understanding that we are admiring chemical burial grounds. We build theories about the religious significance of the Nazca lines, afraid to see in them pragmatic marking of transport routes. This truth is uncomfortable. It strikes at the pride of humanity, accustomed to considering itself the master of nature. But ignoring reality does not change the fact that we live on a depleted site. The planet was exhausted, reshaped, and, apparently, abandoned when the resources that interested the miners ran dry. The left infrastructure collapsed over time, the quarries were flooded with water or covered with sand, and we, arriving at this place millennia later, began to invent fairy tales about gods descending from the heavens to move stones with the power of thought. However, even these conclusions are just the tip of the iceberg. If the land represents the remains of a quarry, what did the giant water spaces we call oceans hide? After all, if the Earth was totally processed, water could have become the ideal way to hide the most massive traces of this process. Ahead of us lies a breakdown of a topic that will make you doubt the reality of geographical maps and the very nature of the water element. If these facts made you think and look at the world differently, support the video with a like and send it to your friends. Together, we can assemble the full picture of the past. Be sure to subscribe to the channel so as not to miss the next episode, in which we will analyze in detail why oceans actually do not exist and what is hidden beneath their surface. See you soon!